to the next concept within the lecture here, and we're going to be looking at 1.2.4, and this will talk about more math functions in Python. All right, so we're going to look at more math functions in Python. If I just scroll back up to 1.2.0, we saw how to print numbers. 1.2.1, we saw the different number types, right, and how to access and print those number types. And then we saw basic operations, right, like minus, division, square, multiplications, modular operations. But we know those are not the only operations that are available in math, right? There are way more operations in math. What about square root, right? What about changing the sign? If I wanted to take a positive number and convert it to a negative number, how can I do all of that within Python? All right, so that's what we're going to be looking at here within this particular concept, because Python offers a whole library, a whole list of ways, of methods that or functions that you can use to work with numbers even more. All right, and we're going to be going through some of those. So in order to do that, I'm going to use a variable here. So I'm going to say my let's just set a variable to a number and say my age equals 30. All right, so that's my age equals 30. Very basic number. So we can go ahead and we can print my age. We should know how to do this by now in our sleep. All right, because Python, very straightforward for us to do that. So my age equals 30. And we can go ahead and we can print my age. We should know how to do that. Now, what if I wanted to do something different? What if somebody wrote a mistake and they said minus 30, my age equals minus 30? Bear with me, that doesn't make sense. Somebody cannot be minus years old. But we want our Python program, if it sees that, to correct for that mistake and to print only the positive numbers, right? So the way we can do that is we can say print instead of and then we can say my age, but we need to do something to this my age. There's a function called absolute. All right, so we use absolute my age. So what absolute? And it's same as absolute in mathematics. So absolute in mathematics, let me just search that really quick. All right, so absolute value describes, this is a little bit of a complex definition. So absolute value describes the distance of a number on the number line from 0 without considering the direction from 0. Absolute value of a number is never negative. So basically, what this is saying, I'll take that from mathematical terms into English, is that take the number and convert it to positive. If it's minus 5, it's 5. If it's 5, it's 5. So whatever it is, look at it as a positive number, right? So in this case, my age is minus 30. I can now take that. If I do the absolute, so it's just ABS, right? And then you wrap that in my age. And if I print that, it's gonna, here it's gonna print minus 30, but now here it's gonna convert that into the positive number. So if you had any number, so here is minus here, but this second one is positive. So if you had any number, you wanted to get the absolute for it, all right, you can simply just take that, wrap it around the absolute function, and that would convert the number to positive. So this is an example of some of the functions that Python makes available for us to start being able to work with numbers, right? Because if I go back in here, everything I was doing here, like minus is on your keyboard, division is on your keyboard, multiplication is on the keyboard, modulus is on the keyboard, but there is no key on the board, on my keyboard that says this should be an absolute, right? But you don't have to worry, because Python provides that function for us, and we can simply call that function for this to change the sign of a value. So think about this as just simply changing the sign of a value to a positive number. All right, and there's way more. We can go ahead and we can say print. All right, and we can take there are more functions, right? We can say there's a function called power, and we can take two numbers, right? We can say 5, 2. All right, let's say you wanted to take a number and raise to the power of something else, right? So say take 5 to the power of 2, right? We know what this should give us, right? 5 to the power of 2 is simply 5 squared, and that should be 25. All right, and that gives us 25. You can literally raise any number to any power, right? I can say that raised to the power of this is that. That would be a very big number, but Python is gonna do it for us. Wow, that's actually a bigger number than I was imagining. You can see. All right, imagine trying to do this with your calculator, all right, or something that you have on very small calculator. Yeah, it will never give this to you. All right, and that's where Python really starts becoming powerful for scientific calculations now, because I can work with crazy numbers like this. All right, the old I don't have it around here, but the old Casio calculator, or Texas Instrument calculators that you used to have in college, or depending on where you're studying this, would never give you this kind of numbers. But now, because of Python, we can actually get this kind of numbers, work with crazy numbers, right? We can really go ahead and work with all kind of crazy numbers, right? Whereas calculators will never. Let me actually go as crazy as I can here, see if there is a limit. See, it's taking a while for this to run. All right, because this is this might end up crashing my system, because this is a crazy calculation. All right, I don't even think anybody can realistically figure out this number. But if you really wanted to calculate this kind of thing, you can leverage something like Python and be able to work with those crazy numbers. I'm just gonna stop this so it doesn't maybe crash my system. My memory on my machine is small, but if you had a big machine, and this is what some of the data scientists and computational mathematics people are doing, they're literally being able to take Python, leverage all these mathematical functions, and they do all kind of calculations with it. So if you've ever been wondering, but why Python? Why don't I just use my calculator? Why do I have to worry about Python? Because now with a tool like this, you can start doing all these kind of calculations that will never ever be possible on my tiny calculator here. All right, so Python can just run and crunch at this, and then it will come back with the results to you. You're right, you might need a bigger CPU, you might need like a GPU, and some of these very fast supercomputers, but again, this is what data scientists, machine learning experts, people with AI are kind of using Python for. I just thought I would throw that in there, because sometimes we might be working with all these numbers and you're saying to yourself, but Fru, explain to me why this makes sense, right? This is just basic, this is rudimentary stuff. Guys, these are building blocks to really amazing things you can be doing with numbers within Python. So this is fundamental. All right, let me make sure that I remove that so it doesn't crash that. Let's actually keep that very small. All right, so what else can we do? There's a lot more we can do. We can print, take two numbers, and then we can say max, or let's say you had multiple numbers, right? You can have 5 comma 1 2 comma all right, so I can have a list of numbers as such. Okay, it's a long list of numbers as such, and I can tell Python which one of these numbers is the maximum. If I have a list of numbers the way I've written them here, and I want to figure out which one of them is the maximum, I can use the max function within Python, and it will tell me the maximum number. So this is raise power, this is maximum, this is absolute. Let me make sure that we name those. All right, so now manually I can really look at this and try to figure out, it's I'm not sure, it's just a lot of numbers, but if I just run my code, guess what, it tells me 37. all right, let me keep this simple. It tells me 37. all right, so imagine you had a list of 10,000 numbers and you wanted to figure out which of them was the maximum. You can go ahead and try to manually figure it out and scan and look at it by yourself, or you can just write the Python code, put in all those numbers into Python, and it's going to figure that out for you. So that's how Python can be very powerful. all right, and we can do maximum. We can also go ahead and do minimum, right? Because we don't always have to do maximum. We sometimes want to say show me the minimum number. Here we just simply change our function to mean, and we can now get a minimum of all the numbers, and in this case it was, the minimum is 2. all right, and you can use this to write a program that takes your students averages, and you want to find the maximum one, the student with the highest average or the highest grade point. You take a student's GPAs, and you want to find the minimum, the student with the lowest grade points. That way you can rank them and that way you can congratulate the one with the highest grade point, and then maybe provide more tutoring for the one with very low grade points. All right, so that's the power of Python. So Python can allow us to do that. Now let's continue going down the list. We can print, say we're working with numbers, doubles, and we can have 5.57. all right, so let's say we have a number 5.57. that's we've seen that this is a float according to Python. But what if we want to round this number, right, to the nearest integer, to the nearest whole number? In math, it's the nearest whole number. So we can say print round, and we can round this to the nearest whole number. Now guess what? It rounds this to 6. But what if I did 4? That, right? Because it's less than a half of that, is going to round it down. So if it's above the lowest, above the half point, it rounds up. If it's below, it rounds down. So now it's rounding down to 5. All right. Let's see. Some of you guys will say, what if I put 50 in there? It rounds it up to 6, right? So it takes from 50 and above, right? So, but if I went to 49, then it's gonna round it down. All right, and I encourage you to take any numbers. It doesn't have to be one decimal place. You can go as many decimal places as you can. This is still gonna round down. All right, and be able to play with it and see how you can round numbers. But let's look at another concept here, which is called so let's say round up and down. All right, let's look at another concept here called, let's say we wanted to specifically round this number down. I don't care whatever whether it's above or below that half point. I want to round it down. So you can use the concept of floor. All right, so you can use the concept of a floor, and then we put in that number. So let's write round down. So floor, think about, you have a house, you have a ceiling, you have a floor. So if I'm somewhere here and I say take this to the floor, boop, I'm taking it down, right? If I'm here and I say take this to the ceiling, I'm rounding up, right? So floor, down, ceiling, up. Very basic. All right, let me make this that way. So it's gonna round that down. Oh, voila. Okay, so now this is gonna give us a very interesting concept here. When I said floor, it complains. It says name floor is not defined, and this will now come into the concepts of libraries or packages within Python. If you're not familiar with that, just hang on. I think it may be in the module 8 or around module 8 or module 7. That's covered. So check it somewhere there if you find that. Otherwise, let me know. But basically, some of the functions are pre-built into Python, but some of them you have to manually import them. So just take it for now. If you have this error, just hover over this, right? And then click on import math.floor. All right. And what is done is, if I go back up here, let me actually copy this to the top. So what is done is it's added this new line for me within my code. So it said from math import floor. So it's gonna import the floor package. That way I can use that function to say floor, because if I don't import this, it will not work. So just for now, just go up to the very first line of your code and type from math import floor. All right, and I'll talk a little bit about this because we're gonna see another issue that will come up here in a second. So now if I run this, this should round this down to 5. All right, even if I had this as 5.999, it's still gonna round to the floor of 5. All right, it's still rounding that to 5. Now let's go ahead and change this. There's another function called ceiling. Let's do 5.01. all right, and I'm gonna say seal. All right, actually I didn't spell that correctly. All right, so you see it still has some issues. If it asks me here, it will say, well, I need to still go import ceiling from that math library, and I can click on that, and if I go up Where is that? For some reason it doesn't put it on my first line of code, so let's just find where that is. All right, so actually it's put it there. All right, it said floor, and now it said comma ceiling. All right, so for me to be able to use this ceiling function is imported that. So assuming that I needed another function, let's say middle, right? If a function existed called middle, will I have to come in here and type that? All right, or Fibonacci's or fabs and things like that. That could really be annoying to do. So another way that you can solve that problem is just to say math.import star, and it's basically going to bring anything within this library, the math library, for us to use. That way you don't have to be physically telling it bring ceiling, bring floor, bring absolutes, bring Fibonacci, and all of those things. So it just makes life a lot easier. So if you type in from math import star, is going to bring in everything. And if this doesn't make sense to you, I'm going to be covering this a lot more in some future videos, so just stay tuned for that. All right, so now if I run this, so since I'm doing ceiling, remember ceiling is what? Up, right? Even though I'm saying 5.01, if I just did round would round it to this down, right? Round would just round this to 5. But because I'm saying ceiling, I'm saying you have to round this to the nearest biggest integer, not to the nearest integer, to the nearest biggest integer. Then ceiling by force, think about ceiling up, rounds it up, right? If I did floor, it would take it down. All right, so that's some of the power of the math library. We can go ahead and do something like let's say we have a number 25. All right, and we wanted to figure out square root. All right, you can use the square root function. All right, if I give you a number and say find me the square root of this number, all right, you can just simply use the square root function, and we know the square root of 25 is 5. All right, so it gives us 5 right here. All right, so these are some functions that are available within Python for us, some mathematical functions. There's a lot of functions that are available. This is just like the tip of the iceberg. Whatever you might be thinking about doing in Python, all right, mathematical base, guys, there is probably a function somewhere that you can take advantage of to be able to work in Python. So it's just a matter of searching around and you can find the function to use. Let's just say I go crazy with this. This might take a while. Let's say that. All right, imagine somebody asks you to find the square root of this. How would you even start to figure that out? All right, but in Python, now I have a value here. All right, it's kind of a decimal floating point value, but you still get a value. You still get a value. If I square this number, I'm gonna get this. All right, so that's it for this particular concept within this lecture. So what I'm gonna do is I'm gonna end that.